Well, Your Excellencies, ladies and gentlemen, honoured guests, thank you so much indeed for joining us in the Digital Theatre of Arts, live down here at the World Government Summit and live at this year's much anticipated GX Talks. We come together to educate, to debate, to collaborate, and to rap a little bit as well by the sounds of things as well. But listen, we come together to open our minds. So, first and foremost, why are we here? Why in this packed arena? Well, GX Talks is, as you well know, a series of dialogues. It's been created by the government of Dubai to forge a platform that unites government decision makers, not just here in the region, but worldwide. Enthusiastic visionaries, many of whom are with us here today, global practitioners, and of course, renowned innovators, to do a lot of to re-examine, to redefine, and to relook at the government experience of the future. This is where we give you insight to the future of government experience. So 2018 is when we launched, and since the inception there, GX Talks has hosted upwards of 35 sessions now. Close to 60 thought leaders. We're about to add another 15 to that number this afternoon. 50 organizations have been recognized, 12 knowledge partners, and have achieved a global footprint in its reach. A reach to educate, to debate, and to collaborate. So we ask you to sit back, to enjoy, to listen to a number of presentations, as I said, from thought leaders and innovators. Open your mind, but also have your say. And we've made it nice and easy for you, because all you have to do is to scan to tweet, all right? If you have not got this in your hand, if you've not thrown it on the floor, you're probably sat on it at the moment, because it was on your seat. QR code, scan it, get involved. You've got all the hashtags there, the handles that you can use to share your thoughts, to share your opinions, and to get your thoughts over to the team so we can collate that as part of the ongoing discussion. GX Talks continue to provide glimpses of the future, highlights of integration of humanity and technology and innovation in the times to come. So without further ado, we thank you all for joining us down here. For those that haven't been to an event like GX Talks, we like a bit of pace. We like to keep things moving. We've got, as I said, a number of opinions, a number of speakers who have flown in from no fewer, well, all corners of the globe for this particular event, and it's great to have them here. So in that keeping, we're going to move things forward. There will be a little bit of a break, a musical interlude, if you like, halfway through, an opportunity for you to pop outside if you need, or do stick around and enjoy some traditional Emirati music here in the theatre. And then equally, at the end of it all, we all get together for a bit of a powwow, a little bit of a natter, and some networking. I think that's what they call it outside, straight after. Okay, so without further ado, feel free to get involved. Feel free to share your thoughts as we welcome the first of our speakers to our stage down here in the Digital Theatre of Arts. And I said we have a truly international lineup for you today. And the first one is what is titled How to Control the Weather, a case study into supervillainy and government as well. Fascinating title. Looking forward to this one. I'm very much looking forward to the man who is going to be presenting. Let's talk geoengineering if we can. Let's get down with Ryan and some geoengineering. He is a New York Times best-selling author. He is an Eisner Award-winning science writer. And he's all the C's as well. He's a cartoonist, he's a computer programmer, and he's a Canadian. And he's with us here today. Put your hands together for Ryan North.
Hi. I'm Ryan North. I'm a writer of fiction and nonfiction and all sorts of things, but a lot of what I do is comics. And if you haven't heard of me, that's totally fine, but you've probably heard of characters I've helped write, characters like Spider-Man, or the Fantastic Four, Johnny Storm, the Avengers, Maria Hill. And I'll tell you a secret about writing comics. And the secret is the superheroes are fun, but the real fun are the villains. They're the charismatic ones. They're the ones who have actual plans to change the world. And yeah, they're the bad guys. And yeah, they don't always succeed because we make them lose as writers. But there's a lot of potential in what they're doing. There's a lot of fun in what they do. And a while back, I started thinking, well, how credible are these supervillain take over the world schemes? You're working in the real world with actual science and technology. No shrink rays, no magic hammers. How close can you get? And it turns out you can get really far. And I want to walk us through one of those plots today. So this is a world domination scheme that is interesting, it's effective, it has a social good, and it is shockingly affordable. So this is the How to Control the Weather, a case study in Supervillainy talk. But don't worry, we're all in the right place. This is actually going to talk about government and governance too. So, I'm a writer. You start with motivations. Why do you want to control the weather? Why would anyone want to control the weather? And that's pretty straightforward. We all live on Earth. All our stuff is here. But sometimes the weather makes it an uncomfortable place to be. And this is an actual image of our planet taken from Earth by NASA, where there are 5 simultaneous hurricanes on it, with a 6th one developing. We could probably do better than that. But supervillains always want to think big. And if you're thinking big, you're thinking, well, can we go bigger than hurricanes? In fact, why are we talking about controlling the weather when we could talk about controlling the climate? Let's go as big as we possibly can. And here again, the motivation makes a lot of sense. The climate has changed since the Industrial Revolution. We put CO2 in the atmosphere. That's increased the level of atmospheric CO2, obviously, and that's caused temperatures to go up globally. And if we want to take over, govern the world, we want it to be a place where people aren't fighting over increasingly scarce drinking water and habitable land. So our motivations here are pretty clear. So where do you start with controlling the climate? Where do you start with fixing this? And the obvious approach is, well, let's clean it up. Let's take this CO2 and get rid of it. But there's a problem. And the problem is that carbon dioxide is diffuse. Yes, it's 420 parts per million, but that's 0.04% of the atmosphere. That is one molecule in 2,400. So carbon capture technology can work great in places like smokestacks where carbon dioxide is really dense, but in the larger world, it's like trying to find a needle in a planet-sized haystack. Bit of a challenge. So, that's not going to work. What about trees? They're the original carbon capture technology. Could we just plant a whole bunch of trees and solve this problem? And the answer is, yeah, we could have a long time ago. But today, to bring the atmospheric CO2 back to pre-industrial levels would take 9 million square kilometers of trees. To put that in perspective, that is 2 India's worth of surface area, or 40% of the Earth's habitable, arable land. And you cannot get rid of almost half of Earth's farmland without killing a bunch of people. So this is also, unfortunately, out. So what do we do? If we can't capture the carbon, if we can't clean up by planting trees, how are we going to solve this problem? And I will tell you how we're going to solve this problem like a supervillain. You, acting alone, are going to create a powerful and sustained artificial volcano. And this is the best slide of any deck, the volcano facts slide. When a large volcano erupts, it can change the Earth's climate in a couple ways. The first is by putting ash into the troposphere. That's the part of the world, part of the atmosphere where we spend all our time. It's where weather happens. And you can shoot ash up there to block the sun, which works, but only for a little bit, because it falls back to Earth, rain washes it out. What we want is someplace where there isn't weather. What we want is someplace where these materials could last for a really long time. What we want is the stratosphere. So this is the second way volcanic eruptions can cool. They put sulfur dioxide up into the stratosphere. When it's up there, it reacts with water. And this reaction produces sulfuric acid. Sulfuric acid, once it's up there, interacts with dust in the stratosphere, coalesces around it. Sulfuric acid plus dust gives you an aerosol. An aerosol is really just a white haze that's sitting up there in the stratosphere. And what a white haze does is it reflects sunlight. So sunlight comes towards this white haze, bounces off it back into space before it can warm the ground that we're on, and this produces a cooling climate and a slightly dimmer one. And the advantage we have is it only takes a 2% reduction in light to bring global temperatures back to pre-industrial levels. Better still, stuff in the stratosphere can hang out there for a year or more before it falls back to Earth. So we're doing great. And you might think, if you know your science, you might think, hey, Ryan, this sounds an awful lot like what happened to the dinosaurs when a giant asteroid hit and it blocked out the sun, and didn't they all die? And the answer is yes, but we will just be more careful than that. So, what is our plan? Easy 4 steps. Step 1, we need a chemical precursor. This can be sulfur dioxide, this can be ammonium sulfate, this can be anything that produces a white haze. Will do it for us. Step 2 is to get it up. Sorry, my deck is not moving ahead. There we go. Step 2 is to get the chemicals up into the atmosphere. Step 3 is to spray them out in tiny droplets to make an aerosol. And step 4 is to repeat this once a year. And that's it. We have successfully taken a warming climate and replaced it with a cooling one. Problem solved forever. Or so you might think. But you might think, Ryan, there's got to be some roadblocks here. You're cheating somewhere. Maybe making sulfur dioxide is hard. How do we make sulfur dioxide? And the answer is it's really easy. It's the only output of reacting sulfur with oxygen. You burn it, you get sulfur dioxide. Done. So you might think, okay, well, maybe getting sulfur is hard. Maybe it's not an easy material to find. And again, it's not a problem. It's the 10th most common element in the universe. It is the 5th most common element on Earth. And it is the 4th most common element by weight. This stuff is everywhere. So we're doing good for sulfur. Everywhere. But then you might think, okay, well, Ryan, I still think you're cheating. How are we going to move the sulfur dioxide in the stratosphere? Because you glossed over this earlier, but the stratosphere is 20 kilometers straight up. How are we going to get it there? And if you know your planes, you'd think planes only go 14 kilometers straight up normally. They stay in the troposphere. And all this is true. However, the US government stands ready to assist us with the Lockheed U-2 high-altitude aircraft that has an operational ceiling of 21 kilometers straight up, well into the stratosphere. And because this is existing technology, we know how much it would cost. For 24 planes, which is what it would take to produce this haze, it would take about $7 billion US to buy the planes and to convert them to spray gas out into the stratosphere. Plus, since this has to be done yearly, you have about $2 billion in yearly operational costs. If you don't like planes, there's other options. You could do a hot air balloon with a hose, sending it up to Earth. Not super practical, but it could work. If you want to think like a Canadian, in the 50s, we worked on cannons, giant cannons to launch satellites into orbit, and they didn't work, but they did reach the stratosphere. So you could shell the skies themselves with sulfur dioxide to do this, to solve this problem. It's not going to be as cost effective as a plane, but it's a very charismatic supervillainy way to do this. So, $2 billion in yearly cost plus $7 billion in startup costs. This is a shockingly affordable scheme within the personal wealth of many people alive today. And when you compare it to the cost of unmitigated climate change, which is $600 trillion US, this is a stone cold steal. So you might think, this is easy, this is affordable, this uses existing technology, and this solves a literal problem. Why hasn't anyone done it yet? Which brings us to the downsides. And I promise they're not what you think. You might think, okay, if you stop seeding the skies, then everything catches up all at once in the space of a year. All climate change happens right in that year. And you're right. Maintaining this haze requires constant technological intervention. But so does farming. If we stopped using nitrogen, we would not produce enough food to feed everyone alive today. We as a species have long ago decided that it's worth relying on our ingenuity to keep everyone alive. So that's not really a concern. You might think, okay, well, what about acid rain? That could happen by putting sulfuric acid in the stratosphere. And yes, that would happen, but the effects of that are orders of magnitude less than that of climate change. Like, this is a win here. We're doing less damage than we could. You might say, okay, well, we've never altered the atmosphere before. And this is true. There's uncertainty in doing this. But you don't have to alter the atmosphere if you don't want to. You could always just put giant mirrors in space to reflect sunlight away from the Earth and keep everyone cooling it down that way. The issue is that there's always going to be uncertainty. We can't predict what will happen, and any technology can be misused. What if people turned those mirrors around and burned us all like ants? This would be a problem. So uncertainty is always there. But the real issue here, all these issues aside, the real one is that of culpability. Who do we blame when something goes wrong? Who do we blame for the weather? Because today, when there's a tornado or a flood or a drought, we call these acts of God because no human can be held responsible for what happened there. Once you've changed the climate, when there's a tornado or a flood or a drought, there will be people who blame you for doing this because your actions have changed the global climate, you've changed the global weather. This is not great. No one wants to be held responsible for that. So you might say, can we mitigate this? What if we didn't bring the world temperatures down to pre-industrial levels, but just brought them, say, halfway? This would only affect water in about 1.3% of land, which is great. Everything sounds good until you realize those people who you've only helped half of the way might blame you for not doing more. Why didn't you solve this all the way? Why are we still suffering? It gets real messy real quick, and that's even before I consider people who think that if there is to be a global thermostat, why do you get to control it? Why don't I control it? I am going to control it. I'm going to take it from you. That's the challenge here, and the problem is that this idea of geoengineering, of changing the Earth's climate to solve climate change technologically, works on paper, but it falls apart when you start to consider human nature. And what began with the best of intentions has instead become a recipe for war and chaos and disaster. Because weather is now political, and every natural disaster now unintentionally but irrevocably has human desires behind it. In a perfect world, this would work, but we don't live in a perfect world. We have humans all over ours, which brings us to the message of what I want to say. There are no technological solutions to social problems. And when you find something that seems to work, if you remove the human element out of it, what you actually have is something that's creating more and worse problems down the road. And I hope when something comes across your desk, a new technology that promises to solve something, and a lot of them could work, whether it's geoengineering, genetic engineering, Web3, metaverse, blockchain, anything, any solution that only works when you take the human out of it isn't a solution at all. Thank you.